So why metrics? Logs are typically unstructured and you would be mostly using to find the needle in the haystack searches. And logs mostly contain the details about what is exactly happening in the application or the system it's tracking. When compared to metrics, it's structured data and it's order of magnitude larger compared to logs. And metrics data are mainly numerical data points, which is mostly used for monitoring and later used for alerting. You'll be mostly tracking the system performance or the application performance, and Splunk provides a log and also metrics as one platform. We can use the logs and along with the metrics to analyze and investigate data. So typically you'll use metrics as the starting point to figure out if there is a problem in the system, and later you'll use the logs to drill down and identify what part of the system is malfunctioning. So what is a metric data point? So it's a tuple of 4 things: timestamp, metric name, and the numerical data point. So all these 3 are required if you want to store data in the Metricstore, and you can optionally have dimensions. So dimensions can be host name, the data center from which you are getting the metrics. Basically, these are optional, and you can use this in your searches later to slice and dice the data. This is going to explain about the time series, that we have this notion of metric time series. In this, like each row represents a metric data point. And when you see the row 1 and 3, they are representing the yellow color. Both of them, they have the same metric name and the same dimensions. If you have data points which have the same metric name and the same set of dimensions, so they constitute a metric time series. Metric time series are co-located when we save them in the metric index. That's how we optimize when we are storing data in the metric index. And that's how we optimize during the MStat searches. Later, Alan will talk about that.
Starting from Enterprise 7.0, we provide a dedicated Metricstore solution for ingesting and query metrics data in a large scale. So now, with this dedicated solution, you can use a new search command called mstats, which is equivalent to tstats for querying the event index. But mstats is a constraint querying language just for metric index. Being a metrics database, it also has the catalog information. So we also provide a search command called mcatalog to let you query the metrics catalog information, such as dimensions, the metric names from your database. And we also have a set of REST APIs just to make your apps or UI easier. So in this table, we showed you the schema of a metric data point. So here you can see the red color fields are required fields. The metric name, for each data point, you need a metric name and a timestamp and a numeric value field. You can also add a bunch of key value pairs as the dimension fields to help you slice and dice your data at the search time. Also, besides those required and optional fields, at ingestion time, we added a bunch of internal fields, such as the _dim, which is convenient for getting the metric catalog information, like the dimensions in your database. You can also group by the result by metric name, so you can get all your dimensions for each metric name.
So the typical use cases that we have seen in the field are like if you have Windows Performance Monitor data, which typically has a lot of metrics embedded in a single event line. There wasn't an easy way for our customers to do that. The log2 metrics aims to solve these problems at the ingestion time frame. So if you have log which has multiple metrics in it, you can use the log2 metrics feature of the ingestion time to extract the multiple metric data points in a single event line and send it to the Metricstore. For using this feature, you need to list the metrics or the measurements that you are interested in. And also optionally, if you are not interested in some of the high cardinality fields within the log event line, so you can optionally list them and we will discard those high cardinality dimensions if you are not interested. So here you have a sample CSV file which has a bunch of numeric measurements, and each data point basically contains the same metric measurements that you want to save it in Splunk's Metricstore. I will ingest this using the log2 metrics feature. Step 1, I have to create a new source type. So I go here and create a new source type. So this is a Windows Performance Monitor data. So I'll just create one. For category, we have added the new log2 metrics category here. And choose the metrics tab, save the measurements that I'm interested in. So just copy paste that and save it. So once I have the new source type saved, I can add the CSV data into the system and need to select the data. This is the CSV file that I just shared with you. And step 2, select the source type that we just created, the Windows performance source type. And next step is to create a new metric index for it. Or if you have a metric index created already, you can just use that. So I'll just create that and save it. And that's pretty much it actually at this point. This is how to create even more sophisticated log data. In this, you can see 2 patterns here. The first 3 events have the group equal to Q. And for the group equal to Q, you have like 5 set of measurements there. And for the bottom 3 events for group equal to pipeline, you have about 3 measurements there. In total, you have like 2 different set of data points, 2 different set of events, where based on the group, you have different set of measurements over there. So this is more complicated than the CSV data I was showing earlier. This would also be typically how you might be seeing the log data, which is pretty much unstructured. This is probably more common if you have a different log data like the Apache logs or something. It might be more similar to this. How to extract the metrics from sophisticated logs like this? What we are going to do is there is an ingest time eval feature, which is primarily similar to the search time eval, which lets you do some evaluations. So we take advantage of that. And here we know, based on the pattern, group equal to Q pattern, and also the group equal to pipeline pattern, we can predict the measurements that you would get for those patterns. Taking 2 of this together, we would write new ingest time eval, which would create a new metric name field. We have to create the new metric name field that I've highlighted here so that the logs to metrics converter would just need to look for this metric name field and does not need to do a lot of parsing to figure out what kind of type does it even belong to. We want to do it efficiently, so the only thing that you as a customer has to identify is like, how can we identify the pattern here? But here you have the group equal to Q pattern. You can use the group name as the token that lets you identify what are the measurements that you have to index for that. You write an ingest time eval, which basically says metric name equal to group. So metric name can be either a group is equal to Q or pipeline. Let's consider the first case. If the group name is Q, when it hits the log to metrics converter, for the Q, you will only look for the associated 5 measurements. We don't need to try to index all of the measurements because each log line has a different set of measurements. That's how we try to simplify and make the ingestion process more efficient. Like, you might not be interested in indexing all the measurements in a log line. In those scenarios, like, we also give you the flexibility. The metric schema blacklist for the Q lets you blacklist or drop selected fields that you're not interested in so that you don't need to bloat your metric index. These are the tunables that you can set if you have a more sophisticated log where each event does not contain the same measurements. So once you have the data in, how would you know whether you have all the metric names and the dimensions that you are interested in the system? The way you can do that is the yum catalog command. The yum catalog command lets you list all the metric names. In the first example that I have here, you do a yum catalog values of metric name, and for the data that I've shown before, so you have the group equal to Q followed by the measurement that you ingested. This is the pattern we follow for storing the metric name when you index log to be stored as metrics. On the other side, I've listed out the dimensions that we have indexed from the previous example was the group, name, and processor. So until this point, I have explained about how to get log to metrics in the ingestion time frame. So if you already have log data and you want to transform those log data into the Metricstore, at the search time, you can either use yum collect or yum event collect to re-ingest the data into a Metricstore. So this is also one other popular option if you already have the data in your log index and you want to save it in the Metricstore. Yum event collect is very similar to the log to metrics in the ingestion time frame. The only difference is it lets you take multiple measurements from the log events and save it in the metric index at the search time. mcollect lets you turn a report into metrics. So in the example that I have here, so you can see I have the index and followed by I'm doing a stats on that. Once I have the stats results, in order to send it to a metric index, you need a metric name and a value. I have to rename the count as value and the type as metric name here. Before I send it to a mcollect, I need to have a metric name and underscore value. I have to rename it and send it finally to a mcollect. Finally, you will get all of the stats data indexed in the mcollect my metrics index. Similarly, for event collect, like you can take the streaming data from the log index, do an eval. So on the log to metrics, basically you'll be using the ingest time eval. Here you'll be using search time eval, construct the metric name using the prefix, and send it to the event collect. Here you can even send multiple metrics. You can extract from those individual log event, and split equal true essentially means you are splitting multiple metric measurements and sending it into the Metricstore. At the very end, you will list the dimensions that you are interested in. So that helps you to identify what are the dimensions in the data, and everything else is implicitly considered as measurements in the event collect.
When you're doing a log to metrics, does your event get indexed as logs and metrics, or you have to pick one?
Ingestion time, right now you have to choose. If you want to ingest the data, there isn't a way in the UI to choose, I want to store both as log as metrics, but you can always use the clone source type option if you are familiar with that in the transforms, if you want to send both to log and also to metrics. But if you're using the UI, you can only save it in a metric index at this point, yeah.
So, but if you, outside of the UI, how would you do it? Different inputs or clone?
A clone source type basically lets you to have a copy of the data both in the log and the event index. You'll create a source type for the log, and within that you'll say clone source type, and you'll point to a metric source type. So the log to metric source type, and that would copy it and store it and also in a metric index.
So when you ingest it,
Before you start ingestion.
Before you start ingestion.
When in your inputs.conf then?
Right.
In your transforms.conf, there will be a clone source type option.
So there is a special source type called clone underscore source type.
Clone source type.
Clone source type.
Okay, so then you would use that to ingest the log with the clone source type. Clone source type.
Clone source type. Yeah. Yeah.
Okay.
What is the performance impact on doing it at the index time, like converting the log to metrics?
The performance impact, I would say it's minimal. So, like it depends on the data. If you have, like essentially I covered two cases. One is when you have like a structured data like a CSV or JSON. That would be, I think, very minimal because it's just taking the data and parsing it and just splitting it. But if you have the sophisticated log where you have like multiple patterns, then I would say like you have to probably use a heavyweight forwarder if you want to make sure, if you have a large deployment and if you want to scale out properly, I would recommend using a heavyweight forwarder and doing all of this log to metrics conversion within the heavyweight forwarder.